Hello, my name is George Clemens, and this video is regarding my final project in ADTA5240.
This video was recorded using Adobe Captivate, which has a 30-day full-featured trial.
Submission Requirement 1 is to develop a strategy to deploy big data technology in a firm. When considering a big data project, some companies make the mistake of labeling it as only an IT project and not a strategic business initiative. A big data project has a large potential value for an organization, but the implementation of the project can require the transformation of an organization to realize the benefits of the project. A big data project utilizes a data analytics lifecycle, discovery, data preparation, model planning, model building, communicating results, and operationalizing the results. However, prior to starting the project, it is important to have a plan for what a business would like to accomplish with the project. An understanding of an organization's business plan is key to identifying the direction of the project. It is not uncommon for an analysis of the data to reveal additional business opportunities, weaknesses, and issues. The business should have a plan in place for how to deal with these opportunities, weaknesses, and issues. Unless of significant value or import, opportunities may be shelved until the completion of the project. Some weaknesses may be of a magnitude of which cannot be ignored and must be dealt with immediately. Others may be identified and dealt with later. Most issues, such as business process bottlenecks, may be shelved to be worked on later. It is also critical for all of the stakeholders to be involved and to fully support the project. Without the involvement and full support of all stakeholders, the likelihood of success of the project decreases. The stakeholders in a project could be an intelligence analyst, a business analyst, a data engineer, a database administrator, a project manager, a project sponsor on an executive level, and a data scientist. It is also important for executive level management on all levels to be stakeholders in a big data project. While the project is in the data discovery phase, all areas of the project should be constantly analyzed by the stakeholders. Information regarding similar big data projects should be compared to the current project. Domain information is an important consideration when making decisions in this phase. After an initial evaluation is complete, stakeholders should build a hypothesis for resolving the critical issues if necessary. After the discovery phase is complete, data aggregation should be performed on the various data sets. The data should be cleaned and processed at this stage. Domain knowledge and stakeholder involvement is very important at this stage, as the creation of an accurate data set is paramount to the success of the project. The data science team and the stakeholders should plan and build the model utilizing domain knowledge where required. The business problems and opportunities should be clearly defined at this stage, and all departments and stakeholders should fully support the model. Data silos should be discovered and breached by this point. Data science techniques should be used to build the desired model. A sandbox should be created for the testing of the model. Communicating results and the method for doing so is a vital function that should also have the full support of all of the stakeholders. A culture change should be attempted. The benefits of data science should be emphasized and infused into the thinking of all members of the organization. The lessons of the project should be summarized, and metrics should be created to measure the success of the big data project. The results of the sandbox and the plan should be thoroughly examined by a quality control team created specifically for the big data project. After thorough testing, the project should be operationalized into the production department. The success of the operationalization is critical, as the likelihood of success of the project drops significantly if the initial deployment of the project fails. Accordingly, considerable resources should be assigned to the initial operationalization. Submission Requirement 2.1. OpenRefine was used to clean the dataset. OpenRefine was downloaded and installed for a previous assignment, and it was opened, and a browser window was opened with the following URL: http://127.0.0.1:3333. This points to an internal web browser. Server. The dataset sales _record _1 ADTA5240.CSV was opened by clicking on the Choose Files button, then selecting the file, then selecting the Next button. A project was created by placing the name Sales Records in the project name field and clicking on the button Create Project. The number 50 was selected to display 50 records on the page. And here is the project I've been working on. The replacement of the comma in the product name field was performed using the following steps. I clicked on the drop-down arrow on the product name attribute. I selected Edit Sales and then Replace. The comma was entered into the Find field, and the hyphen was entered into the Replace field. The OK button was then selected. This resulted in all commas in the product name field being replaced with a hyphen. The file was saved by selecting the Export button, then the comma-separated value option. The file was then renamed to sales_records_2_1.csv. The software tool used to pre-process the dataset is called OpenRefine. The company that did the initial development of OpenRefine was purchased by Google. This company was called MetaWeb. The original product name was Freebase Gridworks. Google changed the name of the product to OpenRefine, and then made the product open source. OpenRefine is browser-based, but the data is stored locally on a machine. It uses web services. It runs on Macs, Windows, and Linux machines. It requires Java. The data is presented in tabular form, and it supports CSV, Excel, XML, JSON, Google Documents, and RDF files. To provide independent verification that the file was properly preprocessed, I opened it in Excel. If the comma still existed in the file, an additional column would have been visible next to the product name column. Submission Requirement 2.2. OpenRefine was opened and a browser window was opened with the following URL: http://127.0.0.1:3333. I opened the project created in step 2.1 called Sales Records. To verify the state name data, I selected the drop-down arrow on the state attribute. I selected facet and then text facet. The result was the window that you see over here to the left. I visually inspected all of these states here and counted them. I came up with 49, which is, of course, less than the 50 states. And none of the states appear to be misspelled or duplicated. But just in case, I decided to look for clusters. I didn't find any using key collision with fingerprint, in-gram fingerprint, or metaphone. And also looked at nearest neighbor clusters. Did come up with a couple, but they don't indicate that the data is bad at all. So I concluded that the state information if the information located in the state attribute is correct. I then examined the postal code column by sorting it by smallest to largest. I performed this task by selecting the drop-down box, then sort and sort again. I then selected sort by numbers and the smallest first option. I observed 449 records with only 4 digits in the postal code field. I also noticed that the associated states were in the northeastern part of the country. I know from experience that that region previously had 4-digit postal codes, and the current postal codes begin with 0. I then examined a sample of the 5-digit postal codes in the affected states. With the exception of the initial 0, they matched the 4-digit postal codes. I decided to create a new column with 0 prepended to the 4-digit postal codes and the 5-digit postal codes copied over as they were. I selected the drop-down arrow on the postal code attribute, then selected edit column, then add column based on this column. In the new column name field, I entered zip code. I then pasted the following field into the expression. If length value is less than 5, add a 0, prepend a 0 to the value. Otherwise, just place the existing value in there. That's what this formula does, and selected OK. This created a new column with a 0 prepended to the values with only 4 digits. The expression first checks to see if the length of the value in the postal code is less than 5. If it's less than 5, a 0 is prepended to the value in the zip code column. If it's not less than 5, the value from the postal code column is copied over without any modification. To avoid issues with Hadoop or Spark, I removed extraneous items from the attribute names, such as spaces or even hyphens, and in some cases, ID. I did receive some errors that regarding a primary field, so I thought, well, I'll just get rid of anything that might cause a problem. I then deleted the postal code column and exported the file. This image shows the add column based on column dialog box. You can see that the value of that box in this particular case, row 2416, only has 4 digits, 1040, and this formula adds a 0, prepends a 0 to that value and adds it to the zip code column in the new column that's created. For submission requirement number 3, the first step was to upload the sales_records_cleaned.csv file to the Google Cloud bucket that was created in a previous exercise. First, I logged into Google Cloud, and you can see that I'm logged into Google Cloud here. And then I went to the hamburger here and the menu and went to Storage and then Browser. I selected the ADTA5240 bucket and went to the folder, the data folder. And here I uploaded the file. which I've already done. You can see that file right here. I then navigated to the VM instances that I have for the Hadoop cluster and started the cluster. This will take a few seconds. I then established an SSH connection with the master node of the cluster. From the SSH connection command line window, I navigated to the data folder and use this command line to transfer the data file to the master node. I then created a directory in HDFS or in Hadoop using this command line, and then moved the data file to that Hadoop directory using this command line. I then opened a connection to Hive and created a metadata connection to the data with the below commands. This command line starts a connection to Hive, creates a connection to Hive, and the below commands creates the metadata connection. So this line creates the table if it doesn't already exist, and you can see sales records underscore, creates the metadata connection if it doesn't already exist, and you can see by the file name sales records underscore 103 that it took quite a few attempts to get this to work. The following line items label the attributes and the data types. I left most of the data types as string because I was not going to be manipulating that data in any way, with the exception of the sales data. This line item indicates that the fields are delimited, and this one indicates it's terminated by a comma. This one indicates it's terminated by /n. I don't know if this was absolutely necessary, but I had so many difficulties that I thought I would just go ahead and throw that in there. And this one shows that it's the data stored as a text file, and this line item shows the location of the data. As I said, I used a string type for most of the attributes, and I used the below command to confirm that the connection was created. Just illustrating the starting of the Hive connection. Okay. And this command line will show the existing metadata connections. Make sure to enter the semicolon, otherwise it will not work. And you can see sales records underscore 103. I've actually deleted quite a few of these. I googled the command on how to delete these metadata connections. One of the requirements of Submission requirement number 3 is to run a couple of queries. The first query selects the top 5 states where the company has the most number of customers. So I'm going to do that right now. Just paste, paste that information from a Word file. And so we're running the query. The last time I ran it, I think it took 21 seconds. Let's see how long it takes. Okay, 22 seconds this time, and the query gives us a list of the states with the count in each state, the count of the records in each state in descending order. So this SQL statement runs a query on the state attribute, counts the records for each state, and it pulls that information from the sales records metadata, groups it by the state, and orders it in descending level descending order, and limits the amount of the records to 5. The second query selects the top 10 zip code areas where the company gets its best sales amounts. Just paste that in there. So it selects by the zip code field, which is an attribute that I had created in OpenRefine. So it's the zip code data that has been corrected. And it adds up the sales in each zip code, and it pulls that information from the sales records _103 metadata file, groups by zip code, orders it in descending order, and limits it to 10. So you can see zip code 10024 has the highest sales. And then it shows that the sales in descending order in the various other zip codes. It took a few tries, but I stopped the Hive connection, and now I'm starting Spark connection. And now I'm running the very same queries that I previously ran. In Spark. And here's the second query. And as you can see, both of these took considerably less time. Submission requirement number 5 requires an explanation of the speed differences between Hive MapReduce and Spark. A Hive MapReduce server is slower and less expensive than a Spark server. And as shown below, when running the same query on the same data, this is a query, the first query I ran earlier. Hive MapReduce takes 21.1 seconds to complete, and Spark takes 10.4 seconds. That's a difference of 10.7 seconds, or 50.7%. In his book titled Hadoop: The Definitive Guide, Tom White wrote, "Spark is best known for its ability to keep large working data sets in memory between jobs. This capability allows Spark to outperform the equivalent MapReduce workflow, where datasets are always loaded from disk. Spark is written to take advantage of data in memory, and therefore it's much faster. In the image here, you can see the second query running in both in Hive and in Spark. As shown in this image, when running this same query on the same data, again, this is the second query, Hive MapReduce takes 8.6 seconds to complete, and Spark takes 5.3 seconds. That's a difference of 3.3 seconds, or 38.3%. Spark is faster again. Written in the blog titled Apache Hive versus Apache Spark SQL, 13 Amazing Differences, are some of the important differences between Hive MapReduce and Spark SQL. Hive is known to make use of HQL, whereas Spark SQL is known to make use of structured query language. Hive produces schema flexibility, portioning and bucketing the tables, whereas Spark SQL performs SQL querying, as it is only possible to read data from existing Hive installation. Hive provides access rights for users, roles, as well as groups, whereas no facility to provide access rights to a user is provided by Spark SQL. Hive provides the facility of selective replication factor for redundant storage of data, whereas Spark SQL, on the other hand, does not provide any replication factor for storing data. As JDBC, ODBC, and Thrift drivers are available in Hive, we can use them to generate results, whereas in the case of Apache Spark SQL, we can retrieve results in the form of datasets and data frame, APIs, if Spark is run with another programming language. Row-level updates and real-time OLTP querying is not possible using Apache Hive, whereas row-level updates and real-time online transaction processing is possible using Spark SQL. It provides acceptable high latency for interactive data browsing, whereas Spark SQL, with Spark SQL, the latency is provided is up to the minimum to enhance performance. Hive, unlike SQL statements and queries, supports the union type, whereas Spark SQL is incapable of supporting the union type. In the interest of speed, Spark SQL is less flexible and more expensive. I think a very important consideration when considering Spark SQL is that it does not provide access control on a user or group level. However, by not providing access control on a user or group level, and other features such as in-memory processing, Spark SQL can perform much more quickly than Hive MapReduce. This concludes my presentation. Thank you.